Example 2 in section 13.4 is finding the period of a sine curve. Use the graph of y equals sine of 4x on page 852. I have a rough sketch of it here. There, if you look next to the graph on page 862, it tells you that x minimum is 0, x max is 2 pi. It also tells you that the y's go by 1, and it shows you the window is for y equals 2 and negative 2. So, how many cycles occur? Here when we look, a cycle of sine starts at 0, goes to 1, down to negative 1, and back to 0. That's a full circle. If we were to flip that over, it would look kind of like a circle. Okay, so we have 1 there, 2, 3, and 4 full cycles. So how many cycles do we have? We have 4. Okay. What is the period of y equals sine of 4x? So the period of the graph is the amount of time it takes for one rotation, or one cycle to occur. So here we have 1, 2, 3. We want to know how long does it take for one of those to occur. Well, we have 2 pi for a full window, and we have 4 of them. So divide it by 4, and we get pi over 2, which means that every pi over 2, this is 2 pi over 2 or just pi, this is 3 pi's over 2, and this is 4 pi over 2. 4 pi over 2 simplifies to just 2 pi. 2 pi over 2 simplifies to just pi. Okay? So the period is pi over 2. We split it evenly 4 ways. And that always works. We can always take 2 pi divided by the number of cycles. If you notice, this 4 also comes from right here. It's our b value. So 2 pi over b always gives us the period of our function. How many cycles occur in each graph on the bottom of page 852? What is the period of the sine curve? So A, if we look there, it looks something kind of like this. Okay. It tells us it goes from 0 to 4 pi, which means half of that is 2 pi. Okay. How many cycles are here? 2. We have 1 and 2. What is the period of the sine curve? We take our full length, 4 pi, divided by how many cycles? 2. And we get just 2 pi. And we knew that because we took 4 pi, split it in half at the end of the period, and got 2 pi. B, we have rough sketches, right idea. It tells us our minimum is 0, our maximum is 4 pi. How many cycles do we have here? We have 1, 2, 3. Again, sine starts at 0, then we go up to 1, down to negative 1, and back to 0. It's our y value through that circle. So to find our period of the sine curve, we take our full distance of 4 pi, and I got that 4 pi from the information on the right. It says x max is 4 pi. Divide by how many cycles there are. And our period is just going to be 4 pi over 3. Nothing else that we do there. We don't have to simplify it like we did up top. The amplitude of a sine curve here. The graphing calculator screens at the top of page 853 show 4 graphs of y equals some number a times sine of x. Each x-axis shows values from 0 to 2 pi. So 1 cycle, and our period here is 2 pi, just a normal period there. What is the amplitude of each sine curve? How does the value of A affect the curve? So in the left screen, okay, the amplitude is the height, the difference away from 0. How far the curve goes away from the axis, the x-axis or the theta axis, okay, how far it goes away from there. So if we look in the one on the left, y equals sine of x goes just 1 away. The maximum and minimum values are 1 away. So y equals sine of x has an amplitude of 1. Okay, y equals 2 sine of x. Its amplitude, or its distance away from our axis, has a maximum of 2 and a minimum of -2, which means they're both 2 units away. So 2. Our amplitude, guys, is kind of like our stretch and our compression, just like it was before. So it makes sense that the value is in front as multiplication, just like it was in all the other things that we've graphed so far. Okay. And the ones on the right, we have y equals negative sine of x and y equals -2 sine of x. So the negatives here, guys, flip them, just like they did before. They're a reflection. So instead of going up first, we go down first. They go backwards. So if we think about our unit circle, instead of going up counterclockwise, we go clockwise. So our amplitude, though, or our A value, just like it's been for all the other things that we've done, absolute value, quadratics, all the way through, is just the number part. The negative is its own thing. That's its own reflection. So the amplitude here for y equals sine of x, each one of those still just goes 1 unit away. And in y equals -2 sine of x, they each go 2 units away. Okay, 2 units away. Instead of going 1 unit away at the maximum and minimum, it's 2 units away. How does the negative value of A affect the position? And we already talked about that. It's a reflection over x-axis, and that's because it's out in front of the whole thing, and we treat it the same way that we have all year with all the graphing things. Now, the equation of the graph is in the form y equals ax squared. What is the amplitude of the sine curve, and what is the value of A? Here we're looking at the got it problems on the middle of page 853. So for part A, we want to know what is the amplitude and the value of A. If we look there, the maximum and minimum points looks like there's 3 units away, or pretty close to 3. I'm going to go ahead and say 3 units away. It's hard to see in that window for sure that they hit there, but it looks like it. So our amplitude is going to be 3. Our highest point is at 3, and our lowest point is at -3. And here I have them backwards, but you get the right idea. Now, the A value itself, since it's reflected, we go down first. That means it's a -3. That whole A value is -3. The negative part is a reflection, and the 3 is like the stretch part. Now, for the second one, for B, okay, there, if we look, it says the second line is 0.4, which means each one of these goes up by 0.4. So we went up 3 lines, but each line is worth 0.2. So we actually went up 0.6. Our A value is 0.6. Because it's positive, that also happens to be our amplitude. Our highest and lowest points are 0.6 away from the x-axis. Take note on page 853 is the properties of sine functions. Absolute value of A is the amplitude of the function. B is the number of cycles in the interval from 0 to 2 pi. And we use 2 pi over B is the period of the function. When we graph sine functions, we can use 5 points to draw 1 cycle of sine. As long as A is positive, pattern is going to be 0, maximum, 0, minimum, 0. And this happens at pi and 2 pi This is 3 pi over 2, and this is pi over 2. We take 2 pi and divide it into 4 pieces. So we take 2 pi divided by 4 and get pi over 2. We take that times 2 to get the second one, which is just pi, times 3 to get the third, which is 3 pi over 2, times 4 to get the fourth, which is 2 pi, and that's how we get these 4 values. So the sine curve, our 5 points are there, 0, 1, 0, -1, and 1. And this should be a little bit more curvy. Mine looks pretty boxy there, but they should kind of curve. And then we just keep repeating that. So we can go on forever in both directions with the same pattern. What is the graph of one cycle of a sine curve with amplitude 2, period 4, midline y equals 0, and a greater than 0? Then what is the equation of the sine curve? Okay, amplitude is our height. Our period is how long it takes us to have one cycle. This midline y equals 0, guys, just tells us that it hasn't been shifted up or down at all. So it's still going to be based off of starting at 0 and ending at 0. And a is greater than 0 means it's not reflected, so we're going to go up first. So what I usually do is I split them into the 4 pieces, and I go by 3s, and I'm not really sure why. I just always have 4 pieces. So I like to, rather than changing my drawing, I just change my scale. So I put 4 pi here, and I take that 4 pi and divide it by 4 pieces. And I just get pi, which means each one of my tick marks is going to be a pi. And then 2 pi, and then 3 pi. Okay, we can do the same thing with our amplitude if we wanted. I'm going to make this point right here be 2, and this at -2. So I'm going to go by 3s again. No rhyme or reason to why. And here we go. I've got my midline at 0, positive, so I'm going up first. My 5 points, 0, max, 0, min, 0. I have my amplitude labeled as 2, my height, and my period is 4 pi. And I just draw this little guy in. And it continues on in both directions. As far as my equation goes, y equals, since a is positive, it's going to be a positive a value, a equals 2. And my b value, uh, 2 pi divided by b equals 4 pi. So multiply by b, I get 2 pi equals 4 pi times b, divide by 4 pi, and I get b equals 1/2. So 1/2 x.